My face, my beautiful face. All right. F of x is equal to x minus 2 cosine x. We're going to determine places of minimum and maximum, as well as intervals of increasing and decreasing, specifically on the range from 0 to 2 pi. All right.
Critical value.
Step 1, find the critical values. Walk me through it, Michael.
All right, so you gotta take the derivative, which would be 1 plus 2 sine x.
1 plus 2 sine of x, that is correct.
Right.
Again, bound by the same interval.
Then you gotta set it equal to 0.
Set that equals 0, so 1 plus 2x, so sorry, 2 sine x equals 0. Now what?
Subtract 1 divide 2, so you get sine x equals 0.
And here, unit circle memorization is very important. Dealing with the interval between 0 and 2 pi, let's find our critical values. Where is sine equal to negative 1/2?
7 pi over 6 and 11 pi over 6.
7 pi over 6 and 11 pi over 6. Okay. Now, remember, since this is on the interval, we can also have the possibility of 0 or 2 pi being a max or a min. It's a good idea to check those. Let's start with the basic one, intervals of increasing and decreasing. So we know we have our two critical values. In order to treat it between 0 and 2 pi, let's determine intervals of increasing and decreasing. Start off, take a little graphic. We have 7 pi over 6 as one critical value, 11 pi over 6 as our other critical value. We need to test the following intervals between 0 and 7 pi over 6, starting value and ending value, between 7 pi over 6 and 11 pi over 6, and from 11 pi over 6 to 2 pi. Let's test those three intervals. To start with, we need to pick values that are in those intervals. Test them to determine whether they're going to be positive or negative in terms of increasing and decreasing. So let's look at this first one. Pi. Sounds good to me. So we test pi, determine what's happening on this interval between 0 and 7 pi over 6. The next interval, from 7 pi over 6 to 11 pi over 6. 3 pi over 2. 3 pi over 2, that's a good one. 3 pi over 2. And this last one,
2 pi.
So 2 pi is actually outside the boundaries. So it's possible that 2 pi could work, or it's possible it could not work. This is one where it turns out using the unit circle only gets you so far. So we're going to need a value that is bigger than 11 pi over 6, but it's still not 2 pi. I recommend something kind of random, but make sure it is bigger than 11 pi over 6, but less than 2 pi. 23 pi over 12.
Random.
That is in between those two. And we will need to calculate that solution. Oh, sorry, over 12, right?
Yeah.
Thank you. 23 pi over 12 would work. How'd you get that value? It's very specific.
I multiplied by 2 and then added 1/12 to it.
So you took the 11 pi over 6, multiplied the top and bottom by 2, giving you 22 pi over 12, and added 1 to the top in order to get guaranteed to be bigger.
Yeah.
Perfect. That's exactly what I would do. Other things you could do, you could like take something kind of weird and do like 2 pi minus 0.1 or something. Like just a really small number that just makes it just a little less than 2 pi. So like you could also, like 2 pi minus 0.01. You know, that's definitely in this interval, right? Because it's less than 2 pi. But it is also definitely bigger than 11 pi over 6. So you have a lot of weird alternatives you can go with. Practice makes perfect on these kinds of problems to determine which ways you can go. Okay, unit circle can help with 2 out of these 3. Let's do it. Pi. If I plug pi into my derivative, what do I get?
1.
1. What happens when I do sine of pi?
0.
Get 0. 2 times 0. Plus 1.
1.
So that's a positive value. So that tells me that this interval is positive. We're going to plug in 3 pi over 2.
No, 3.
Nope.
Positive? No.
What is, so let's do it one piece at a time. What is sine of 3 pi over 2?
Negative.
Negative 1. 2 times that.
Negative 2.
Plus 1.
Negative 1.
So you get negative 1 here, which tells me this one is negative. Okay. 11 pi over 6. 2 pi, so I wanted to try 23 pi over 12. Get a calculator out. Positive. So 0.2438, you said, I think? 48? Perfect. As long as it's positive, it's only good here, right? Okay, so let's answer the first piece. Intervals.
I don't round weird. I round properly.
Shh. You sure about that?
I can't use fractions. I round to 3 decimal places.
Are you sure that's proper?
I'm not going to write out 30 different digits for a chemistry packet. That's all I'm saying.
It's big things.
I direct choir.
Yes.
Okay, so for this problem, we have the following setup: positive, negative, positive. Let's go ahead and write our intervals of increasing and decreasing. Step 1. Intervals of increasing. This problem, 0 to 7 pi over 6 is one interval of increasing.
And 3 pi over 2.
Oh God.
So what?
3 pi over 2.
Nope.
7 pi over 6. Sorry.
Make sure your boundaries for interval of increasing should be critical values. Okay. Intervals of decreasing. That is the first one. Any more? Not in this range. Okay.
You said that's the first one, so I was like, what?
There are more. They're just
Not
not in this range. So, next up. Maxes and mins. For this, let's use the first derivative rule, first derivative test. Where would I have a maximum? Oops. So remember, these will guaranteed be either local or relative.
7, 5, 6 is
7 pi over 6 is a relative max. You are correct. Now explain why that is the case, Abby.
slope going to 7, 5, 6 positive, and the other side is negative. Maximum.
By the first derivative test. That's the key phrase on an AP exam to look for. Is what you said was perfect. If you don't include by the first derivative test, they'll take a point off. Because what you're saying is correct, but you're not saying why it's correct. It'd be like saying, if you guys ever did speech, I don't know how many guys did speech or like did debate, but when you give a statement in a debate, you have to reference a factoid that goes with it in proper debate. They're just saying, it's true because of this article, it's true because of this researcher, it's true because of this thing. We're saying it's true because the first derivative test. And minimum, Sydney, why would that have to be a minimum? Good. You're missing one phrase that she missed too. By the first derivative test. Okay? That little phrase is 1 point off. Okay? And it's so small, you're just like, serious? But yeah, it's part of justifying your reasons. Is you can't just say, it is. I'm smart, it is. Just trust me. You gotta reference why. And that little, you could even shorthand it. I know some people have typed in like, or written out like FDR, like first derivative rule, or FDT, for first derivative test. Like, but you gotta say, by this test, I know it's right. Yes, according to Joseph Stalin, before he went crazy, this is right.
Yes. According to Hitler.
According to Hitler, some art is better than others. True story. Let's go back to some homework problems. The trick ones. Make sure you've got the unit circle. If you haven't got it memorized from last year or retained it from last year or you didn't have it last year, please take a look at it and get it started. Okay, it is very helpful to have for a lot of these problems. And there will be at least 2 problems on this upcoming test, which will take place probably after Thanksgiving, which will contain questions where you cannot use a calculator and they have to use a unit circle, and that will not be up. You gotta have them. Okay. That's one of those things that if we don't have a homework assignment that night, then your homework is learn the unit circle, work on it, get it down so that you can hit them off every time. Okay. Let's go to. I'll be honest, that's what I have to do too. At the start of every calculus test I ever took that I knew I was going to need the unit circle, the first thing I did was I would take like 10 seconds and quickly draw out a quick unit circle with the big ones that I needed. And usually I just start by doing like just the top, bottom, left, and right, and if I needed more, I could fill in the rest as I went. But that way I didn't have to think about it later on. Because as weird as this sounds, at the beginning of a test, you want to do as many memorized things and just dump your brain. Okay? Because those things are super easy. Like whenever I was in academic team, pro tip I would give you. At the beginning, before you start a round, if you have a top of a blank page of paper, write down some basic formulas that you know might come up. Like the point formula, basic derivative formula. Okay? Your formulas for basic areas, right? Just so you're not going to be in the middle of a round stressing and then be like, oh God, how do I find the area of a square? You know it. Your brain's just in overdrive trying to figure it out, and it's going to stress. And it's better to have that stuff down. Like whenever I took the AP exam the first time, the very first thing I did was I flipped the entire thing over. On the back, I drew a quick unit circle. Because I didn't want to have to sit there in the middle of the test and be like, 30? No, which one? No, doesn't work. Don't do it. You will hurt your brain, and you will make simple mistakes that you wouldn't have made normally. And that shouldn't count against you. But it will. Because that's how tests work. Have the knowledge of foresight to be like, I need to write this stuff down beforehand to prevent me from making mistakes later on. You have to start with a blank piece of paper. They have to hand you a blank piece of paper. But as soon as that paper's in your hand, you can start busting formulas down. Okay, we did this one, we did this one, we did this one, we did that one. We talked about those. We talked about derivative stuff. That was last chapter. We did that one. Woo! Here we go. Okay. 64. I think we did one similar to it. Did we actually do it?
No, this one.
I think 60 was similar to it.
Yeah, we got x minus 3 squared times x plus 1. So yeah.
So a little different. A little different.
It is.
Number 64. Alright. 65 is really interesting. We'll get to it when we get to it. 64. At what values of x does the graph of f of x have a relative maximum? Justify your answer. So because it says justify, if I'm going to use that little cheat in order to use a derivative to determine intervals be increasing and decreasing, if I'm going to use that, I need to reference the first derivative test. So whenever I get finished, when I write my answer, at some point in time, I'm probably going to say by the first derivative test. Either at the beginning of the sentence or the end of the sentence, I know I'm probably going to reference that. I'm just trying to plan my problem appropriately. So let's look at 64. It says, blah, 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 maximum.
Yes.
What does that mean?
Find the maximum.
How do we find maximum?
Find
Find the critical values first. So, step 1, let's find the critical values. I'm going to do all my work in this little space. Alright, how do I find the critical values of this function?
Set that equal to 0.
But normally we have to take a derivative.
It's already derivative.
It's already the derivative. Yes, please read the problem. If they give you the derivative, don't take it again. It's a trap. Read the problem carefully. Okay? We already have the derivative, so all we have to do the critical values is set this equal to 0 and solve. Speaking of which, how are we going to do that?
FTA.
Fundamental theorem of arithmetic.
Yes.
We split it apart. 3 minus x squared equals 0. X plus 5 equals 0.
Sorry.
How we keep going? 3 and negative 5. Okay? So one of those should be probably the minimum, one of them should probably be the maximum, or it might be, you know, like a weird, like, bump. You don't know. That's why we have the first derivative test. Woo! Yahoo!
Yeah.
My mama told me the first derivative test was the best way to find the minimum maximum. Alright? I got -5, I got +3. I need to test around them to do the first derivative test, so how do I test around them? Critical values? We've got critical values, -5 and 3. Oh, pick values. I apologize. Would you pick some values for me, Alexis?
-6,
-6, beautiful.
0,
0, great.
and 4.
Perfect. Where are we going to plug them in? What? Open the door for you. I love you. Nothing personal.
You ever gonna say that from Rowan?
No. And the subs come in today and tomorrow. So if I don't hear anything, I'm
It's one of those single things.
but if not, I'm probably going to start cloning on Monday. Right? Alright, let me know. Thanks, Graham. Okay, that's just fantastic values. Where are we going to plug them in?
And 3 minus x, and x plus 5.
Perfect. So let's start plugging them in. Let's put some more cuts. Sydney, would you plug in -6 for me? Ricky, 0 please. And Abby, 4 please.
Do I have to
We're doing analysis afterwards.
do I try to find a value or negative?
I want to know what whether it's positive or negative specifically.
Okay.
Okay? So, -6, 0, +4. What'd you get?
0 is positive 45.
Positive 45. So the answer is
Positive.
positive. Okay? One down.
Or is positive.
4 is positive. Right? Yes?
I believe so. Well, too.
Big brain.
Is what happens.
Yes. Ow.
Wow.
Wow. I can't.
When I draw, like when I
And then six.
quantity,
Negative. Beautiful. Alright. So I want to determine the maximum. Looking at our 3 pieces, we have negative, positive, positive. We're going to get to the maximum. Perfect. No relative maximum by the first derivative test or first derivative rule. Ricky, explain for me. Actually, sorry, I can't have you explain because I specifically said for Michael to explain this. Michael?
Yeah, come on. What do you need me to explain?
Why is there no maximum?
Oh, it's because according to the first derivative rule, like where it says that you need a positive on the left and a negative on the right, you don't have that. It's written away.
You can put that into words. Fantastic. Okay. All right. 64 is done. There is no maximum. So this is a question that has an answer of there isn't an answer. There is a big difference between I don't know and yo bro, there isn't an answer. Smart students need to know the difference. You guys are smart. Okay? Don't let no answer mean I am confused, I give up. No answer is sometimes the answer. There isn't a maximum. If you were to graph this function, the original function that has this derivative, which is annoying to do, you have to integrate to find that function, but you could do it, and if you did, you'd see that it has no maximum.
How do you not have a maximum?
It has to have a definable maximum. So it could have a max of like infinity or negative infinity on the other side. This function, so let's discuss big brain topics. Look at this function. If I multiply it all out, it would be a cubic function. Okay? If I multiply it out, it would be a cubic function. Which means that if the derivative is a cubic, what's the original?
Step up.
A step up from that. So it's called a quartic.
Okay.
Quartic is 4. Think quarter, 4, quartic. Quintic is 5. Quin, like is in quins from drums. It's okay, and if you forget, just be like it's the 4th power. Okay? So the derivative is a 3rd power, so the original function has to be a 4th power. And think of what a 4th power function looks like. Think of what an even-powered function looks like. The two ends go upwards. or both ends go downwards, depending on whether it's positive or negative. This one turns out to positive, so both ends go upwards, so it doesn't have a maximum. It just doesn't. Okay, 65 is one of the most interesting problems on this homework assignment. I was super sad we didn't get to it because we needed to do this problem first. But now that we have it, I want you to take a look at 65. It's the last problem in the homework. Use the equation of the tangent line to approximate the value of f of 2.1 if f of 2 equals negative 3. These problems are kind of famous in AP because they're different. They tell you what to do, but they say it in a way that makes you feel like you're missing something. So I want to take this problem, we're going to break it down a little bit into one piece at a time and talk about how to find the solution by doing exactly what it says. All the instructions you need are on the board. Ready? Let's take a look. It says, use the equation of a tangent line. Use the equation of a tangent line. Do I have an equation of a tangent line? Y minus y1 equals mx minus x1. To use this equation of a tangent line, I need three things. I need y1, x1, and I need m. Well, coincidentally enough, I either have or can find all three of these things. Let's start with the easy one, x1 and y1.
2
negative 3, right here. So that tells me that y1 is negative 3, because it's the value after you plug in a number. x1 is 2, it's the number you plug in. So independent versus dependent. So now I just need the slope. How do I find the slope? Plug into the derivative. I would need the derivative to do that. Yeah. If you read up above, it says use this derivative for 64 and 65. So I can't scroll out because it'll erase everything. Could you please, what would I plug in to the derivative? No. 2. Because we're investing if we have this point. So we have to plug in this number in to find the derivative.
7.
It's 7. So let me double check mentally. So it would become 3 minus 2 squared, that would be 1. Squared, that would be 1. And then it was 2 plus, 7. Yeah, thank you. Perfect. Okay, so let's write down our formula. Y minus, that would be plus 3 equals 7x minus 2. So we have the equation of a tangent line. What does it say to do? Approximate the value of f2.1. What is 2.1?
The x.
An x value. We're plugging in. Note the trick this problem is trying to help you figure out, but is not telling you up front. It says use the equation of a tangent line. So our first step is find the equation of the tangent line. We can't use it unless we have it. But it has to be the tangent line of this particular point. I can't use a different point because it's the only one I have. If I tried to use 2.1, which is a common mistake on a problem like this one, I don't have the y value for that to plug in the tangent line equation. So I shouldn't use 2.1 for anything over here. Because I can't do it. I don't have enough information. I need 3 pieces of information. I need the slope of x value and y value. The only way I can get that is at this point, right here, the 2 and negative 3. The 2.1 is written first because it's nice to track. Okay, it's trying to trick you into plugging in 2.1, but you need to plug in 2 because it's the only one you can plug in and get both a y value and a slope value. If I plug in 2.1, I can get a slope value. Can't get a y value. Don't have the equation. So let's plug in 2.1 now. So I have y plus 3 equals 7. 2.1 minus 2. Let's solve. I'll do it kind of slow here. 2.1 minus 2 would be 0.1. 7 times 0.1 would be 0.7. So I have y plus 3 equals 0.7. Subtract 3 from both sides. I get y equals what value? Negative 2.3, and that is the correct solution for this problem. Notice how we did it and how the problem was trying to tell us how to do it. But it's not going to come out and say, plug this number to the derivative, then find the value, and I plug the other number in the tangent line equation. It's not going to say all that stuff. I know it should. It would be so much easier if it did. It's going to sit there and say, use the tangent line. So in that statement, it tells you, hey, you probably need a tangent line. If you're going to use it, you need it. Use it for this point at this point. And you have to make a conscious decision and be like, look, if I want to use this equation, which Ricky was kind of provided with, fantastic job, man. If I want to use this equation, I need three things: an x, a y, and a slope. This can give me an x, I can therefore find the slope, but I can't give me a y. This has an x and a y already, I can get the slope from the derivative. So this is the only one that's good here. And then from there, I've got this slope equation. I just plug in 2.1, find my solution. Questions on 65? Okay. Let's do one more trick one. We're going to call it a day. Let's see. We've done a lot where I've given you the derivative already. We've done a couple where we've started out with from the beginning. Let's see who remembers our rules. Yes. Okay. This problem. F prime of x is equal to tangent of x minus 1 times x squared minus 3x minus 4. F prime equals that thing. Find relative minimums and maximums. So the main thing does not change. We're going to do critical values, starting with step 1. In this case, set it equal to 0 and solve. So I take my derivative. Set it equal to 0. And now we're solving. How do we solve this? Oh, and specifically, we're going to have an interval, let's see, between negative pi over 2 and pi over 2. That's a common one for tangent.
From the right polynomial, can you break it into x minus 4, x plus 1, and then do the fundamental theorem of arithmetic?
Sure. So his suggestion was to take this function, to take the right-hand side, it's a polynomial, break it into two parts by factoring, I assume, and then use the fundamental theorem of arithmetic to find each solution from each piece. That's a good solution. Good way to go about it. Let's do it. Tangent of x minus 1. We've done nothing with the first one yet. The second one becomes, you said x minus 4, x plus 1?
Yeah.
Equals 0. All right, now we're ready to do.
No.
Fundamental theorem of arithmetic. How are we going to break this apart? You notice I'm being big this time because I want you to get it right with a trig one this time.
Tangent of x minus 1 equals 0.
Perfect. First one. So we used the fundamental theorem of arithmetic a couple times. Second one.
X minus 4 equals 0.
X minus 4 equals 0. And the third one.
X plus 1 equals 0.
X plus 1 equals 0. All right. Let's we can go in any order to solve these three. So you might want to do the easy ones first.
Nah, like that.
Huh?
X equals 1.
You
Okay.
know your brain power on the hard ones, the easy ones are just easy.
You say so, man. Our brain dies after a little while.
Yeah, X equals 5 pi over 4.
5 pi over 4?
Yes.
That is not in the interval.
Solution.
There is another one where it's negative 1. First of all, Abby, to get the unit circle's tangent values, you take the y value divided by the x value. So to find tangent of 0, you would take 0 divided by 1 and get 0. To find it for pi over 6, you take 1/2 divided by square root of 3 over 2. You have to do some canceling and simplifying. But that will tell you the tangent value. Square root of 2 divided by square root of 2, square root of 3 over 2 divided by 1/2, 1 divided by 0, 1 divided by 0. So that's why pi over 2 is an asymptote. Pi over 4? Pi over 4 does work. Tangent of pi over 4 is 1 because square root 2 over square root 2 becomes 1. Alright, the other two. X minus 4 equals 0 and x plus 1 equals 0.
4 negative 1.
4 negative 1. Okay. Sorry, I should put 5 pi over 4 here as well to verify that it is an answer. It's just not an answer we want.
That's not how to do the unit circle. I thought you subtracted a negative from 2 pi, and that's how you find mixing up rules. I need a trig. I need trig rules.
If you like, I have a couple.
I may have to take one. I need to get a trig.
And I can also send you guys a copy of the Crowder one from last year if you guys would use it. I'd be happy to. There's a physical book back there. If you look on the bottom shelf, I do believe there's a couple different variations of the trig book. If not, the bottom shelf might be all Calc books. The middle shelf from the bottom should be trig and algebra books. Feel free to take one.
Does 4 not work?
I may have a bunch. Ricky?
Does 4 not work?
Why would 4 not work?
Because it's not the domain.
Correct. Pi over 2, so pi is 3.14, cut that in half, that'd be roughly 1.57, give or take, pi over 2. 4 is bigger than that. So they got two values. Negative 1 actually works because negative pi over 2 would be negative 1.57, negative 1 is still in that range. So yes, fantastic next catch, very nice. We got 2 left to test. So catching these eliminates extra intervals that you have to test. That's why you look for them, okay? Let's go ahead and do our interval testing. Okay, we got negative 1. We have pi over 4. Ooh, mixing whole numbers and pi values. Oh yes, I'm looking forward to this, okay? I got 3 intervals. My intervals are from negative pi over 2 to negative 1. That's the first interval. Second interval is from negative 1 to pi over 4. Third interval is from pi over 4 to pi over 2. Unit circle can help with finding some values that fit in the range. I just on the previous one, though, that does not always get all of them. I think this one does have a couple ones that are nice and some that are not as good. I need a number that is between negative pi over 2 and negative 1.
Negative pi over 4.
Negative pi over 4? 3.14 divided by 4 would be less than 1. It actually works in here, but would not work on that side. I need a number between negative pi over 2 and negative 1. All right. I'm going to pull out a piece of trig that you may not remember. Very helpful. Why don't we convert negative pi over 2 into decimal? What is negative pi over 2 as a decimal? We already did it before, but let's do it again. Negative pi over 2 as a decimal is?
1.57.
So I need a number between negative 1.57 and negative 1. You don't have to use a unit circle. You can just use a decimal as between those two. Okay, don't let that ever throw you off. You are allowed to use any decimal, any value that exists between these two numbers. If you're having trouble finding one in the unit circle, then just convert them to decimals and try to find one in between them that you can use. Use the unit circle first because those have predefined values. They're easy to do by hand. If that fails, this works too. Okay, just find a number in between. So I need a number between negative 1.57 and negative 1.
Negative 1.5.
Beautiful. Negative 1.5 is definitely between those two. Now, between negative 1 and pi over 4. This one you probably don't need to convert to a decimal, is it? 0. 0 is definitely between a negative number and a positive number. Okay, right hand side, pi over 4 and pi over 2. Pi over 3, perfect. That's a unit circle. So I can do 2 of these with the unit circle. One of them, I would definitely need to calculate for. Okay, so I gotta plug it in. I can either plug it into the original right here, or this other version, it will still work. Now I'm gonna use as many different tricks as I can for this. Let's do it. Ready? Negative 1.5, I'm going to do last. It's the hardest one for me to do. 0 is the easiest. I'm going to do that one first. Plug in 0. Tangent of 0 is 0 minus 1. This is a negative number. 0 minus 4, so I get a negative. So I have a negative times a negative, positive. Okay, one down. Calculator is probably going to be necessary for the other two. Because I can do one of them on the right hand side and the other on the left hand side. One of them is always going to be easier than the other. Negative 1.5, I could probably do the right hand side pretty easily in my head with some practice. But the left hand side, never going to happen. Whereas pi over 3, I could probably do the left hand side in my head using the unit circle, but then plug pi over 3 into the right hand side and numbers get weird. So let's split this up. Michael, would you plug negative 1.5 into that original equation, please?
Positive.
You get a positive? Okay. And plug in pi over 3. Positive. All 3 are positive? Double check that, please.
Yeah.
Always double check. While you're doing that, I'm going to pull up Desmos.
Negative.
It's negative. For pi over 3?
Yeah.
If you see something weird, check it. Yeah, it happens. It could have also been that all 3 are positive. We don't know. This is a weird function. That's why we check. Okay? Always make sure to check. This is never going to happen, apparently. I'm going to just leave that up eventually. Alright, we got 4 minutes left. Come here, Desmos. Desmos. Yay. Alright. Remember, this is the derivative function. So positive values indicate positive slopes. Negative values indicate negative slopes. Let's make sure and verify this. So at first I have parentheses, tangent of x minus 1 times x squared minus 3x minus 4. I want this to be bounded between negative pi over 2 and pi over 2. So what I'm going to do is I'm going to make x equals negative pi over 2. This will create an artificial boundary on the left-hand side. And x equals pi over 2 on the right-hand side. This is a little cheat you can do on some graphing calculators.
You can actually do it like you can do it like a visualizer because there's limits on it.
Okay. Alright. So this time we got critical values at negative 1 and pi over 4. So let's go here. This should be at negative 1. Beautiful. Should be at pi over 4. Beautiful. Okay. This one says the 3 intervals. This one says negative 1.5 should also have a negative value based on the picture. Can we double check negative 1.5, please? Make sure it's in radians. It has to be in radians.
Oh, let me see. Oh, there we go. Misplaced it negative somehow.
Ah, okay.
There we go.
Is that being negative? Good thing we checked. Okay. As I told you before, simple mistakes are often the most common mistakes you're going to make in a class like this. Because there's just a lot of stuff, right? The more stuff you do, the more likely you're going to make a mistake. The more times you drive your car, the more likely you already get in the car. Fun facts. I know, right? Okay, so minimums and maximums. Let's use what we got. Where are we going to have a local or relative maximum? 4. Why is that?
Positive, negative, positive, or
You were so close, but you missed a point.
by the first derivative rule.
There we go. So by the first derivative rule, pi over 4 should be a maximum. You were so close. 9 out of 10, 90%. You still got an A, but doesn't feel as good. Okay? And let's see. That's this. Where we have a minimum.
What was the max?
The max is at pi over 4.
-1.
Mm-hmm. Why?
Because the fundamental FDT. Negative.
You're confusing the two. This would be the first derivative test.
Uh-huh.
Since we're looking at the first derivative, and we're testing values around it, that's one way you can remember it. This would be by the first derivative test. It would be at -1. Okay? As you can see, the trig ones are no different. They can just add a layer of complexity because they have to find the critical values of now a trig function as opposed to a standard function. Standard functions, don't forget, ways you can find zeros or undefined values. If the function equals 0, so you could do things like factoring. You could do things like fundamental theorem of arithmetic. You could have cases where you have, say, something in the denominator. So if you're dividing by 0, those would be critical values. You could have places where you have a radical. Those could also have critical values. Because remember, we're not supposed to ever have imaginary numbers in calculus. So all those could be there. And with trig, we add the extra complex layer of, well, trig functions often have undefined values or have values of 0 defined by the unit circle. So those can add a layer of complexity. They do not change the problem itself. They add a layer of complexity to the already defined narrative that we are running. That we have to find critical values by looking at the derivative, determining when it equals 0, determining when it's undefined. Any questions to finish out today? Cool. Tomorrow I will be posting your guys' homework assignment. We will have a homework day tomorrow, and it'll be time spent to start it and get through as many as we can. Next week we will continue in this unit's instructions because the first unit test is not the only thing we have. We'll be talking about things like Rolle's theorem and the mean value theorem, which are pretty neat. That's what I'm talking about. But look for the homework to be posted either tonight or tomorrow morning. Okay? Okay.